Lesson 9.1, Graphing Quadratic Functions. We have been working with quadratic equations for a bit now. We've learned how to solve them, how to factor them, and today what we're going to do is we're going to graph them. In other words, we're going to visualize what the function looks like on a coordinate plane. And we're going to draw the graph of quadratic functions. So first, let me redefine a quadratic function for you. A quadratic function is not linear. So the graph of your quadratic function will not be a straight line. And it can be written in standard form, which is f of x, the function of x, equals ax squared plus bx plus c. Now we know that f of x is interchangeable with y. So another way that we can write a quadratic function would be y equals ax squared plus bx plus c. So let's remember that y is always the function of x. X is the independent variable and y is the dependent variable. X is the domain and y is the range. The graph of a quadratic function is called a parabola. It's called a parabola. It looks like a U, and it could be an open U, a regular U, or an upside down U, depending on the function. So there are characteristics about a parabola that you need to know. A parabola is symmetrical. That means that there is a line, an invisible line that you can draw on a parabola, which I've drawn a red dotted line, where on either side of the line you have the same exact image. Okay? It is symmetrical. So you can find the axis of symmetry by following this equation. X equals negative b over 2a. So we can find where that axis of symmetry is on a parabola, on an equation, by plugging in b and a into that equation, x equals negative b over 2a, and that'll tell us where that axis is, axis of symmetry. And we can also identify the y-intercept, the place where the parabola goes through the y-axis, and that is c. The y-intercept would be c in our quadratic equation. Okay, a few more characteristics that you need to know. When a, in your equation, when a is greater than 0, in other words, a is positive, the parabola will open upwards, and the lowest point on the graph is called the minimum. It's also called the vertex. And when a is less than 0, in other words, when a is negative, the parabola will open downward, and the highest point on the graph, the vertex, is called the maximum. I will teach you two ways to graph a quadratic function. The first is to make a table of values. Okay, so the first thing you need to do if you're going to graph by making a table of values is find the axis of symmetry using the formula x equals negative b over 2a. Select two values for x before the axis of symmetry and two values after the axis of symmetry. Complete a table of values, graph the points, and connect with a smooth curve. So that would be one way that you can graph quadratic functions, and we will practice that method in a little bit. The other way that you can graph a quadratic function is using just the axis of symmetry, the vertex, and the y-intercept. Okay, so the first thing you do here is find the axis of symmetry. Then you would find the vertex by substituting the value above into the quadratic and determining whether it's a minimum or maximum. Is A positive or negative? Then you will find the y-intercept C. Then you will use the axis of symmetry to plot another point on the other side of the axis of symmetry of the y-intercept. And then lastly, you'll connect the points with a smooth curve. Now, I understand these are just steps that you're writing right now, and it's hard to imagine what you're doing, but I'm going to take you step by step on our examples. So just write the notes, and then after you see an example, you can go back to the notes and make more sense of them. Okay. Graph by making a table of values, state the domain and the range. Take a moment to pause the video and copy down number 1. Set up your coordinate plane, set up your table of values, write down the equation. Get ready now to work with me. So hit pause and then hit play when you've set up on your graph paper all the elements of this problem. Okay, so the first thing we need to do is find the axis of symmetry. Let's find that invisible line that goes through the middle of our parabola and that causes mirror images on both sides. So we're going to use our equation x equals negative b over 2a. So here we go. X equals negative b would be, if b is positive 4, then the opposite of positive 4 is negative 4. Over 2 times a, which is 2. So negative 4 over positive 4 would be negative 1. So my axis of symmetry is along x equals negative 1. I'm going to draw a red dotted line as the axis of symmetry. You don't need to do that, but it's going to help you for this problem to see how symmetrical or how the symmetry works. Okay, so we know that that parabola is going to be symmetrical, and that axis of symmetry is that red dotted line that I've drawn. So I'm going to go ahead and complete the table of values now. The next step is to choose 2 points for that are below the axis of symmetry. So I'm going to choose negative 3 and negative 2. Then we have negative 1. And then 2 x's that are above the axis of symmetry, I'll choose 0 and 1. Okay, now you have a bunch of arithmetic to do. So for each of these x's, what you need to do is you need to plug them into our quadratic and solve for y. So where x is negative 3, y is equal to 0. Where x is negative 2, y is equal to negative 6. Where x is equal to 1, y is equal to negative 8. Where x is equal to 0, y is equal to negative 6. And where x is equal to 1, y is equal to 0. You should pause the video and make sure that you run these x's through your quadratic. Practice running the x's through and making sure that you get the correct y's. Okay, now go ahead and plot those ordered pairs on your graph. Okay, I've plotted the points. I hope you have too. And now the challenge to draw a smooth curve through these points, making a parabola. So I'm going to try my best here. Kind of hard with the stylus, but there we go. So here is your parabola. As you can see, it's a perfect parabola. The axis of symmetry divides that parabola right down the middle, causing a mirror image on either side. Now, the next part of this question says to state the domain, that is the x values, and the range, that is the y values for this parabola. The domain is really all real numbers. X, there's no limit on x. So you would write your set notation, And inside your set notation, you would write x can be all real numbers. X values have no limitation. But let's look at the range, the y values. If you notice, this parabola has a minimum. And if you notice, the minimum is at the vertex that is right there. And so y does not go below the vertex at any time. It stays above the minimum. So for your range, y, all values for y, where y is greater than or equal to -8. See, y cannot fall below the minimum on the parabola. Okay, let's continue. For numbers 2 and 3, we're going to look at a graph and we're going to identify the following. We're going to identify the axis of symmetry just by looking at a graph. We're going to identify the vertex of the parabola and the y-intercept. The other thing we're going to do is we're going to identify whether the vertex is a minimum or a maximum. So pause your video, take a moment to copy these two graphs, and then come back and we will identify these elements of the parabolas. Okay, so I've color-coded each of these so that you can see what we're referring to here. So the axis of symmetry, recall, is that vertical line that divides the parabola into two mirror images. Okay, and I can see that the axis of symmetry is at x equals -1. And I've color-coded that in red for you. Okay, the next thing we have to identify is the vertex. The vertex and whether it's a minimum or a maximum. The vertex is the point that I've indicated in the light blue. It's at -1, +5. That is the vertex. And we know it's a maximum. Just looking at it, we can tell that it is a maximum. Okay? And the third element that we're to identify here is the y-intercept. Where does this parabola cross through or pass through the y-axis? So the y-intercept is at 0, 2, +2. Okay? Pause the video. Answer these questions for number 3 on your own, then come back and check your work. Okay, check your answer. Okay. Now what I'd like to do is go ahead and use the formulas to answer the same question. We're going to identify the axis of symmetry. We're going to identify the vertex. We're going to then identify whether it's a minimum or a maximum, the vertex, and we're going to identify the y-intercept. So, copy down number 4. Okay, to find the axis of symmetry, we will use -b divided by 2a. So, b in this equation is +6. Negative b, or the opposite of b, would be -6 over 2 times a, which is -3. So we have -6 over -6, so we know that our axis of symmetry is 1. So x equals 1. That is the equation of the line of our axis of symmetry. Okay, so let's go on now to find what our vertex is. What we will do is substitute 1 for x in the equation. So let's do that. Y equals negative 3 times 1 squared plus 6 times 1 minus 1. Go ahead and complete the arithmetic. So when you finish all of that arithmetic, you'll find that y equals 2. Therefore, our vertex is where x is 1, y is 2. Okay, so that would be our vertex. And then we are asked to tell whether that's a minimum or a maximum, and we will know that by the sign of A. A is negative. If A is negative, then we know that this parabola will open downward, and then the vertex is a maximum. Okay, and the last item that we need to identify would be our y-intercept, which is equal to C, which is negative 1. Okay, now we're going to practice the same exact process, and then we're going to use it to graph the function. Now this is graphing the function using the axis of symmetry, the vertex, and the y-intercept. Okay, so let's find the axis of symmetry for this equation. Again, x equals negative b. So if b is positive 4, the opposite of b would be negative 4, over 2 times a, and a is 1, 2 times 1. So negative 4 divided by 2 is negative 2. That is my axis of symmetry. So I can go ahead and draw, I'm going to draw that line in red so that you can visualize it. You don't need to draw it. At first I suggest that you do, so it helps you see where the mirror image, where that center for the mirror image is. Okay, so now we need to find the vertex, and what we will do is, to find the vertex, we will say, we will plug in negative 2 for x. So the function of x equals negative 2 squared plus 4 times negative 2 plus 3. Let's do some math. Negative 2 squared is positive 4. Negative 2 times 4 is negative 8 plus 3. And so 4 plus negative 8 is negative 8 plus 3 is negative 1. So my vertex is at negative 2, negative 1, and I need to know if it's a minimum or a maximum. Well, how do I do that? I need to look at A. A is positive 1, so if A is positive, I know that this parabola opens upward, and so this is going to be a minimum. So I can go ahead and plot my vertex, and my vertex would be right there. Now let's identify the y-intercept, which would be C in my equation. So my y-intercept is at 0, 3. Let's go ahead and plot that point. 0, 3 would be there. Okay, so then the next step here would be to look for a symmetrical point on the other side of the axis of symmetry that goes with that y-intercept. So if there's a point 2 units away from my y-intercept along where y is positive 3, then there has to be a point on this side as well. Okay, and so now my challenge will be to draw the parabola. So let's try that. Okay, excellent. All right, I have attached a few problems for you to do. I want you to do number 1 and number 3. I want you to do number 1, counting by 2's on the graph. And on this one, I want you to use a table of values. And then I want you to do number 3, counting by 1's on the graph. But for this one, I want you to use axis of symmetry, vertex, and y-intercept. Okay, we will work with this tomorrow extensively. God bless you. Have a great night.